So you're in the waves unit and you're getting ready to take the waves measurements quiz, or maybe you already have and you just need some more help with it. This video is found by clicking on this link right here, YouTube Wave Measurements Work-Along video. And to watch this video, what you should do is you should go and you should get file number 7, the Wave Measurements Worksheet, and you should have that file with you, because that file looks like this. It's got this wave picture, and I've got 5 questions here. Down at the bottom of that page, you've got 5 answers, the answers to the 5 questions. I just gave you the quick version. And then if you flip the page over, I tell you how to get those 5 answers, but I spell it out a little bit more thoroughly. So let's get started. Here is the top half of the worksheet, and let's start with number 1. So number 1 says, what is this wave's wavelength? Well, to get wavelength, we know that we're going to be in meters here, and we're going to be looking at distance. So across the bottom here, we go from 0 to 15 meters. So the wavelength, how do we measure wavelength? Here's the easiest way to do it. You find a spot on the wave. Probably the easiest thing to do would be pick a crest, and then you go to the next adjacent crest right here. The wavelength is just from that one crest to the next. Or if you wanted to, you could go from one trough over to the next. That would give you the same answer. I've even seen some kids pick a spot right here, and the wavelength would be all the way to right there. That's fine, but usually I caution kids, I usually tell them just pick crest to crest or trough to trough, because if you pick a spot like this one, you might get confused and you might pick this spot and think that is one wave, but that's not, because if you leave this spot, let's say we're going from left to right, if you leave this spot, the wave is headed down, and if you leave this spot, the wave is headed up. So those two spots aren't identical. If you wanted to have this spot, you'd need to go to here, because from this spot it's also headed down again. Anyway, on this graph then, let's just go with this first one that I looked at. So if I go here, that is a distance of 12, and the next crest back was 6. So 12 minus 6, the wavelength of this wave is 6 meters. So next question says, what is the wave's amplitude? And amplitude, pretty easy to measure from the graph. Amplitude, what we're going to be looking at is we're going to be looking at this vertical distance here, and once again it's just marked out in meters. So imagine a pond, and imagine that the pond was perfectly calm, so the water would be flat. So here would be the pond. And now let's imagine that someone threw in a pebble or something and there's ripples traveling across the pond. So if you were, say, in a little boat right here, you would be up above the 0 point. We call that equilibrium. Or you're in a little boat down here, you'd be down below where the water normally is, or below equilibrium. So amplitude, all amplitude does is it measures the distance between equilibrium and the top of the wave. So it's just going to be 0.04. But you might be wondering, what about this boat down here? Its distance, you might say, is negative 0.04. Well, no, its distance is 0.04. But if you were talking about displacement, like if you wanted to know where is it compared to 0, that would be a vector, and you would say, yeah, my displacement is negative 0.04, but by itself, amplitude is just a distance. It's just a how far. So the amplitude of this wave is just 0.04 meters. Next question, what is its period? Also pretty easy to measure from the graph. If we pick I'm going to pick a wavelength. I'm going to pick this wavelength right here. I'm going to pick this trough to this trough. So there was our wavelength. We already know that that was 6 meters. But now instead of looking at the distance, now I'm going to look at the time. So the distance for one wave we said was 6 meters, but the time for the one wave was this difference right here, this 0.15 to 0.05. So what's the difference between that? That difference is actually just 0.1. Oops, not meters. That is 0.1 seconds. So the period is the time for one wave to go by. And I could have picked this spot up here. If I had picked this spot, that was 0.2, and if I had picked this spot, that's 0.1. From 0.1 to 0.2, that is a difference of 0.1 seconds. So that's how you can get period off of a graph like this one. Next question, what is the frequency? And frequency is there's two ways to do it off this graph, and I'll show you both of them. The easiest way for me is to just look at the relationship, because I know that period and frequency have a reciprocal relationship. So period is 1 over the frequency, and frequency is 1 over the period. So if I just solved my period, that's my t number. If I just plug that in right here, 1 divided by 0.1 is 1 divided by 1/10, that is 10. And I had this seconds on bottom here, so that's 10 per second. So my frequency is 10 waves per second. Quite often, sciencey people, instead of saying 10 per second, they would say 10 hertz. So for some repeating event, people often use hertz instead of per second. So that's one way to do it, and I told you I'd show you two ways to do it. Here's a second way. Let's trace out this whole graph. How many waves are on this graph? There's 1, there's 2, and there's a half. So we've got 2.5 waves. And then now let's trace out or line look at how much time there is. We go from 0 seconds out to 1/4 of a second, 0.25 second. So 2.5 waves divided by 0.25 seconds is 10 waves per second. Or you could say, 10 hertz. Same answers that we got down here. So that's two ways to get frequency off of a graph like this. Last question, get the velocity of the wave. What's its velocity? Velocity, if you've gotten to this quiz, you probably or possibly have already taken the velocity is frequency times wavelength quiz. And all we have to do here is take our number 4 answer and multiply it by our number 1 answer. So our frequency, we said, was 10 hertz. And just so I don't forget that it's per second, I'm going to write it per second instead of hertz. And then the wavelength was 6 meters. So our answer here is going to be 10 times 6, so that's going to be 60. And we've got meters, and then we've got per second, so we've got meters per second. So this wave, whatever it is, it's probably not a water wave, a ripple on a pond, but this wave has a velocity of 60 meters per second. There you go. Good luck on the quiz.